I'm Andrea Davis, and I'll be doing problem number 4 from AB 2013 test. So this problem gives us a graph of an f prime, and it gives us information that says the figure above shows the graph of f prime, the derivative of a twice differentiable function f on the closed interval. 0 is less than or equal to x, which is less than or equal to 8. The graph of f prime has horizontal tangents at x equals 1, x equals 3, and x equals 5. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 8 equals 4. So part A of this question asks us to find all local minimums of f. In order to find local minimums, we look at the graph of f prime and we try to find where f prime equals 0. So we find 3 places where f prime equals 0, x equals 1, x equals 4, and x equals 6. In order for it to be a local minimum, we need to find a place where it goes from the derivative being negative to the derivative being positive, and there's only one place on the graph where it does that, which is x equals 6. So we know that the answer to part A is x equals 6 because f prime of x equals 0 and f prime changes from negative to positive. Part A is worth 1 point, and the 1 point is given for an answer with justification. Moving on to part B asks us to find the absolute minimum of f. So we know that the possibilities for the absolute minimum are any local minimums and the 2 endpoints. So we know from part A that the only local minimum on the graph is x equals 6. And so our 3 possibilities for this answer are x equals 6, and our 2 endpoints x equals 0 and x equals 8. To find f of x at 6, we need to evaluate f of 8 minus the integral from 6 to 8 of f prime of x dx. We know from our original information that f of 8 equals 4, and we know from the graph that the area of f prime of x from 6 to 8 equals 7. So we can now replace f of 8 with 4 and the integral from 6 to 8 of f prime of x with 7. So we know that f of 6 equals 4 minus 7, so that is negative 3. Going back to our 3 possibilities, we now evaluate f of 0. f of 0, to find it, we use f of 8 minus the integral from 0 to 8 of f prime of x dx. And again, we know that f of 8 equals 4. And looking back at our graph, we know that the area from 0 to 8 will equal 12 by adding up all the areas that it gives us here. So our new equation for f of 0 is 4 minus 12, which we know is negative 8. And going back to our 3 possibilities, our last one is 8, and we know that f of 8 equals 4 from our original information. So our 3 possibilities now look like this. Our f of x of 0 is negative 8, of 6 is negative 3, and of 8 is 4. So we can clearly see now that the absolute minimum of f of the graph of f is at x equals 0, and our absolute minimum equals negative 8. This problem is worth 3 points. 1 point is for considering x equals 0 and x equals 6 for the absolute minimum. 1 point is for the answer, and 1 point is for justification or working out your problem. Moving on to part C. Part C asks us to find the intervals on f where the function is concave down and increasing. If we look back at our graph, we have to find areas that are concave down by finding where f prime is decreasing. So we find multiple areas where f prime is decreasing, but we also have to consider that we want f to be increasing, which means f prime needs to be positive. So where f prime is decreasing and positive, we find from 0 to 1 and from 3 to 4. So that is our answer. So we know that those are both concave down because f prime is decreasing, and the functions are both increasing because f prime is positive. Part C is worth 2 points, 1 point for the answer and 1 point for the justification. Moving on to our final part, part D. Part D gives us additional information that there's another function g of x, which equals f of x cubed, and also gives us that f of 3 equals -5/2, and asks us to find the slope of the line tangent to the graph of g at x equals 3. So first, we need to find the derivative, which is what we're actually looking for. We're looking for g prime of 3. So we know that g of x equals f of x cubed. So using the power rule and the chain rule to take the derivative of g of x, we find that g prime of x equals 3 times f of x squared times f prime of x. As we plug in 3 for all of these, we get a new equation, g prime of 3 equals 3 times f of 3 squared times f prime of 3. And now going back to find number values for these, we know that f of 3, as it is given to us in part D, equals -5/2, which we can plug in here. And we also know from our original graph that f prime of 3 equals 4. So now going back, we have a new equation, g prime of 3 equals 3 times -5/2 squared times 4. As we simplify that, we get our answer that g prime of 3 equals 75. This part of the question is worth 3 points, 2 points for finding g prime of x, and 1 point for finding the answer.